All right, time to begin arithmetic class. Time for arithmetic class. Are you talking? Nick, are you talking? Logan, are you talking? Is everyone quiet now? I hope you know I'm teasing you. Everyone is quiet, and now we are beginning our arithmetic time. And let's begin by going over a few of these problems here. 1 peck equals, say it out, 8 quarts. Kilo means 1,000. Hecto means 100. Deca means 10. Deci means 1/10. Centi means 1/100th. Milli means 1/1000. 1 centimeter equals 10 millimeters. 1 ton equals 2,000 pounds. 1 minute equals 60 seconds. 1 foot equals 12 inches. 1 yard equals 3 feet. 1 quart equals 2 pints. 1 metric ton equals 2,000 pounds. Good job for that. And now we're going to go and we're going to reduce the fraction. Reduce the fraction. Ready? 8 twelfths can be reduced to, did you say 2/3? Good job. Can you say it before I do at home? Then you know, then I know you know how to do it. 2/5. Now this one's improper, so you need to change it to proper. So, who said 4? Good job. Divide the denominator into the numerator. 5. What's that one? 3, 6, 1/2, right? 1/4. 10 over 25. 10 over 25, what is that? 2/5. 1/2. Raise your hand if you got every single one of those correct. And you know how to reduce fractions. What about decimals? Decimals, like we did before. I'll give you a decimal, you give me the fraction. See? 10th, 100,000. So you would say 11,000. 41 hundredths. 111 thousandths. 20, what would you say? 21 thousandths. 10th, 100,000. So there's 3 places, so it would be 1,000. That's how many zeros would be. However many places past the decimal, that's how many zeros that you would have. Say it, 3 thousandths. Good, good. Now, what about this? Now say the decimal. What would the decimal be? 0.9 or 9/10, right? How about this one? 0.131, right? Yes, and that's how you would do those. If they give you a fraction, you can write the decimal equivalent. And if they give you a decimal equivalent, you can write the fraction. Together, intersecting lines. What is that? I don't think we did that one the last time, but this is simply called a simple closed curve. This is any shape, then this is representing any shape that is a simple closed curve. Now, a rectangle could be a simple closed curve. It's just, the lines don't intersect and it's a shape. That's all that means. Now, in this case, we've got like just half a circle or semicircle, but that's just an example of a simple closed shape. And this here, we haven't gone into the exact shape of this, but we're going to call this just a polygon. Okay? A polygon is a type of simple closed shape that we'll be talking about. Perpendicular, good job. Congruent angles. Right angle. Ray. Line. Line segment. It has 2 points at the end. From this point to that point. It's a segment of a line. It's a piece of a line. Good job. Point. Angle. An angle is 2 rays. Rhombus. Parallelogram. Notice the difference between rhombus and parallelogram. Trapezoid. Good job. Did you know that was a trapezoid? Rectangle. Rectangle. Circle. Triangle. Square. And parallel lines. Lines that run in the same direction, side by side. But they don't have to be right side by side, but in the same direction, at the same angle, are parallel lines. And they do not intersect. Right? Well, we're going to look for a minute at the book. Before we do that, we're going to review just a couple things. And I think it would be easier to show you by just looking at my paper that I have right here. So look at the paper right here. So let me show you my piece of paper that I have here. And I thought it would be fun to take a piece of paper and a strip of colored paper. And I have drawn some degrees on what would be, looks like a Fahrenheit scale. And if I were to take my paper and put it up to a certain number, could you tell me which one it is? And you know how many lines each one is, so that's 30, right? Then I will go up to this one here. And what if I had it, and I'm going to zoom in here. What if I had it right there? What would that be? How many degrees Fahrenheit is that? It's what? What is it? And it fell off, but what was it? Raise your hand if you said 43 degrees Fahrenheit. Who said 43 degrees? How about 42 degrees? Who said 42 degrees? It's 43 degrees. Give yourself a pat on the back if you said 43 degrees. Why? Because look, that's 40, right? That's 42. That would be 44, right? So in between 42 and 44 would be 43, right there, 43 degrees, right? Not quite in 44, but past 42, about there, would be 43 degrees. Do you understand how that works? Understand how that works? Now look at this paper here. I've got some story problems we'll work on. I've also got a measurement. I always say measurement, but I mean solving the unknown equation. Let's go over this one right now too. The first thing we're going to do, Emma, is what? Yes, we're going to write down the part we can solve first, right? And Skylar, what is that answer going to be? Did you say 13? You are exactly right. Good job. And then what are we going to do on this step over here, Leah? Yes. We're going to rewrite what is already there. And then we're going to do the opposite. -3 plus 3 equals, and Colin, what are we going to write here? Yes, we're going to write 13 because we always bring down what was there. 13. And what did we put beside what was already here? A plus 3. And what we do to one side, we must do to the other side. Plus 3, right? So now we go, oops. Now we go like this. A minus 3 and a plus 3, we say cancels out, right? So we're left with just n equals 13 plus 3, Michael. Yes, 16. Did you say 16 before I did? Good job. I'm drawing a line there because that's what I think is going to be my answer. Let's test it. How do we check it, Alice? What do we do? Yes, we rewrite our equation sentence inserting what n equals. 16 minus 3 equals 8 plus 5. Let's see if they equal. What's 16 minus 3? Is that 13? Is 8 plus 5 13? Yes, that checks correctly. Therefore, this is true. N equals 16. Then we go on to our story problems. Our story problems, I'd like to tell you about something that I think many of us do, but when you are solving for story problems, do this. Write down all the information you need to solve the problem. So for example, I could read my story problem out of the book, and it says, the bookstore at Victory Christian School sold 14 boxes of pencils that contain 96 pencils in each box. Each pencil sold for 12 cents. How much did all the pencils cost? And what I did on my papers, I simply wrote down the information I have to solve it. So look for numbers and then the things that the numbers represent. So 14 is for the boxes of pencils. 96 is for the number of pencils in each box. 96 pencils in each box. And the pencils were sold for 12 cents each. This is all the pertinent information I need to solve my story problem. Well, what does the story problem ask us at the end? It asks us, if you look at story problem 6a, how much did all the pencils cost? Well, we're going to look for money then, right? 12 cents each. Well, in order to solve for how much all the pencils cost, we have to know how many pencils there were. So we first have to solve how many pencils are there. Well, there's 96 in each box, but there's how many boxes? 14 boxes. 96 is just, when we see the word each here, that's just in one box. There's 96 pencils in one box. How would we find out how many are in 14 boxes? Is our number getting bigger or smaller? Well, if that's for one box and we want 14 boxes, obviously our number would get bigger to find out how many pencils altogether for all of them. We're going to have to do what? Will we just add them? No, that's for one, and that's 96, 14 times, right? Because there's 14 boxes. Imagine 14 boxes of 96. Multiply by that many times. And so we could do 96 times 14. That will give us how many pencils there are in all the boxes, right? 96 pencils. So that's the first step. But it asks us, how much would it cost? So once we get the total number of pencils, guess what we have to do then? We have to multiply again, don't we? This many pencils, but I'm not going to tell you however many pencils it is, times what? 12 cents. Now what you're going to have to do when you multiply your 12 cents though is we're going to need to change that to a decimal, aren't we? 12 cents as a decimal would be what? That's right, 0.12. That will give us, once we do that and put the number there and multiply by our money, will give us the amount of money. Now, we may need to use a dollar sign here too. So don't forget to put that by the time you figure it. I'm not going to tell you the answer, but hopefully that helps you to learn each day a little better what information you need to write down and how to figure it. It's not the figuring that's the hard part of a story problem, or the often missed part. It's the deciding what to do. Once you know what to do, the solving is fairly simple. It's knowing what to do. Story problem B, 6B. There are 36 oranges for $15.84. What would one orange cost? If this cost is for 36 oranges, but we want one orange. Now, do you see what I did again? I mean, the whole story problem was Mrs. Rosna bought 36 oranges for $15.84. At that rate, what would one orange cost? There we have a clue word again, rate. What does rate mean? Rate means multiply or divide, depending on how they ask it. So then, if we're going to multiply or divide, is our number getting bigger or smaller? There's 36 oranges for that much. How much would one? Is our number of oranges getting bigger or smaller? Smaller. So what are we going to do? Yes, divide. Dividing, because remember the word rate means multiply or divide. So if it's getting smaller, we have to do the one that would get smaller, would make something smaller. Divide. Multiplying makes something bigger. So think logically, is it getting bigger or smaller? And if it's getting smaller and the word rate is there, we know to divide. What are we going to divide? Well, what's there? Yes, we're going to divide, put our dollar amount in our division box when we divide, and put the other number outside the division box. That's important. Most of the time, the dollar amount will go inside, and the number we need to divide to solve goes outside. And before you even start, what I would do, if it's money, as it is in this case, bring it straight up above. Bring the decimal straight up above so you don't forget. And see that dollar sign? Put your dollar sign in the answer. Then, at the end, you will be much less likely to forget. So make sure you do that at the beginning. Then estimate and divide. Solve it. I want to see that you can get the correct answer. Okay? So you work on that. Go through, know your measurement problems. You need to know those in order to solve. 24 yards equals how many feet? Is it getting smaller? Are we going from larger to smaller or smaller to larger? We're going from larger to smaller, so multiply and do your special number and all of those. You'll have some problems like that on your paper too. So make sure you remember how to do that as well. So until next time, you continue working on your paper. You do the things that we talked about in this video, and you sharpen up on any skills you need to. And remember, tell me if there's a certain kind of problem. Mr. Doyle, there's a certain kind I keep missing. Do you think you could incorporate that in the video? And I'll be glad to do that for you. You take care, work hard, and be looking for the next video. Bye for now.